Now, after having looked at the distance between two skew lines or two non-coplanar lines, we will now look at our first case that I had shown you, that is distance between two parallel lines. Obviously, these two lines are parallel, they are obviously coplanar, right? These two lines are coplanar. So, they are in the same plane, obviously, and if they were intersecting, so if they were not skew and they were not parallel, then they would have been intersecting. Only three kinds of lines are possible, right? If it was intersecting, the answer is the distance between them is 0. For the skew lines case, we already saw the formula. Let us now look at this case where your two lines are parallel to each other. So here, these two lines are parallel to each other. Both of them are pointing in the direction B bar, right? Both this line and this line are pointing in the direction B bar. The first line is passing through this point called A2. The first line is passing through this point called A1, and the second line is passing through this point called A2. Which quantity in this diagram, according to you, should give me the distance between these two lines? Right, the answer is TP. If you look at TP, and if I can get the modulus or the length of TP, then I will get the distance between these two lines, right? This TP is what I am looking for. So how can I get TP? So for that, first what I'll do is I'll write the equation to the straight line. And that is your R bar is equals to, let's look at the first line. It's passing through this point called A1 and it's parallel to this vector called B bar. So it's A1 plus lambda B bar. Similarly, your second line is passing through this point called A2 and it is parallel to this vector B bar. So it's mu B bar, right? These are basically the equations of the straight lines. Now, what I need is TP. So basically, if I know TS, then sine theta is equals to, TS by, or TP by TS, basically, in this triangle, if you look, TP by TS. So TP is equals to TS sine theta. So the moment I'm getting this sine theta term, it should give you an idea that we need to use cross product, because once we start from cross product, A cross B, this is where I'll get AB sine theta. This is where I'll get this sine theta term. And I'm looking for the sine theta. So what I'll do is, I will start with my cross product, with my relevant cross product. So what is the relevant cross product here? Let's see that in the derivation. So let's look at this term called B cross ST. B bar cross ST bar. B bar cross ST bar is nothing but mod B bar into mod ST bar into sine theta, right, into n cap. This is your B cross ST, right? So ST is this vector, which starts from S and goes to T, ST, right? So that means I can write ST as nothing but A2 bar minus A1 bar. So B bar cross A2 bar minus A1 bar is equals to, this is mod B bar, and mod ST sine theta. Mod ST is the length, is this length ST. If I do mod ST sine theta, what will I get? I'll get TP, right? We already saw that. So mod ST sine theta is mod TP, which I'm looking for. This into n cap is what I'm finally getting. Now what I'll do is, I will take modulus on both sides. So if I take modulus on this side and modulus on this side, what I will finally get is mod B cross A2 minus A1 is equals to, this is mod B into mod TP into mod n cap. Mod n cap, it's 1, right? What is this n cap? So basically, when I take two cross product, when I take a cross product of two vectors, then after this magnitude, I need to write this unit vector, which is perpendicular to the plane containing B and ST, right? We've already seen this. This n cap is perpendicular to the plane which contains both B and ST. In other words, this n cap is perpendicular to both B and ST. And it's a unit vector, right? So that's why when I take the modulus of this, it will become 1. So I can just remove this. Now finally what I need is TP, and I have everything in front of me. So this is the TP, and TP is nothing but the distance. So the distance is nothing but B bar cross A2 bar minus A1 bar mod. So this cross product of these two will give rise to a vector, and I'm taking the mod of that vector, right? That will give me a positive quantity divided by mod B. Right, so this is the final quantity that you're expected to remember. This is the final formula. So when you have two parallel lines, if you notice that even if you forget these formulas, if you just understand the method as to how they are being derived, even in the exam, you can just quickly do it in your mind. With practice, obviously, you will acquire that. You'll quickly do it in your mind, and you'll be able to get the distance. So This will give me a scalar, this will give me a scalar, the ratio of the scalars will finally give me another scalar, and this scalar is what I'm looking for. This scalar is actually the length TP, that is the distance between two parallel lines. With this, we complete all the topics that we had to as far as 3D lines were concerned. Let's now move on to 3D planes.